Hello and welcome. I'm your host, Adam Hawkins. In each episode, I present a small batch of the theory and practices behind building a high-velocity software organization. Topics include DevOps, Lean, software architecture, continuous delivery, and conversations with industry leaders. Now, let's begin today's episode. Today, I'm happy to speak with Joe Kutner. Joe is an architect at Salesforce Heroku, where he guides engineering best practices. Also, he's been writing and speaking about the 12-factor app for years now. I invited Joe on the show to discuss the 12-factor app and my proposed additions to what I call the 12.1-factor app. If you recall, I did some episodes on dev prod parity, config, and logging. But no worries if you haven't listened to those episodes yet. I mentioned my high-level points from those episodes throughout our conversation. But if you haven't listened to them, then please check them out after this episode. We discussed Joe's opinion on applying the 12-factor app guidelines to modern software and what he would add given today's landscape. We also spoke a lot about dev prod parity in a way that you may not expect. And that caught me off guard, so maybe the same thing will happen to you. Now I give you my conversation with Joe Kutner. Joe, thanks for coming on the show.
Hi, it's good to be here.
So I've already introduced you in my own words. Why don't you introduce yourself in your own words?
I've been working on the Heroku platform for about 6 years. I started as the Java language owner. So I was curating the Java experience on the Heroku platform, making sure that Java developers felt at home and were using the tools that they found natural. I was doing that for a long time, and now I'm an architect, so I'm working a little bit more broadly on the platform and guiding some of the engineering best practices that we hold dear at Heroku.
Yeah, so I guess that's where the 12-factor app comes in. I wanted to have you on the show because I heard your interview on Software Engineering Radio, and that happened to coincide with some of the episodes I've done on this podcast and what I called the 12.1-factor app, specifically like 0.1 because it's an addition. It's not necessarily like changes, but I think it's a broadening of the scope. And after listening to your interview, I think that there's some alignment between us on where we think that it can be expanded upon and some of the, not necessarily the shortcomings, but the changes in which the practices apply in the current context. Maybe we can start off by talking about how is that context different in your experience versus over the years, how have you seen the application of these principles change as the technologies change?
When the 12-factor app concept was first launched, I think it was about 8 years ago, the state of the industry was quite different. I think the apps I was working on were deployed to a server running in a closet down the hallway. We weren't even on the cloud yet, let alone talking about the different options for what infrastructure as a service and whether you're using a PaaS you built yourself or some vendor PaaS. Part of what the 12-factor app was trying to do was teach people the architecture, designs, and principles that were best suited for cloud deployment. Because when we were deploying in those onto the metal on a server that was in the same building as us or whatever, those resources were really precious. We had to fill out some IT form to get a new server, and it took 2 weeks to get it set up. There was an actual cost directly associated with that. We were treating our servers themselves, but the applications that ran on them like pets. We were trying to keep them running all the time. We didn't want to restart them, that kind of thing. But today, the infrastructure that we run on is disposable, right? It's much more like livestock or cattle, where we can buy new ones when we need one at market, and we can dispose of, if something's not working right, we get rid of it. So it's a very different model, and that was just emerging when the 12-factor app was first launched. I think it did a great job of helping bring people into that state of mind. But as you say, that was a long time ago. I've been giving talks about the 12-factor app for at least 5 years, and even for me, the way I talk about it has changed in that time. So I think that says something about its age.
Oh yeah, how so?
Well, when I first started speaking about it at conferences and writing blog posts, I was targeting the Java community. I mean, I wasn't alone. Folks like Josh Long and the Spring team were trying to bring that ecosystem forward to where ecosystems like Ruby already were. The tools in that ecosystem were lagging behind, to say the least. We were really focused on tools like, for in the Java ecosystem, it was the Eclipse IDE and Ant, which was very poor at managing dependencies. And we were trying to move people from those into a way of doing development that was more modern. Again, very much based on ecosystems like Ruby and Node.js. But that ship has sailed. The Java ecosystem has very much modernized. So technologies like Spring Boot and other web frameworks have those kinds of principles that we expect that are more akin to Rails than some of the servers of the past. So when I talk to people, there are points that I would hammer on 5 years ago that I don't even need to talk about anymore. And there are other things that have moved to the forefront, like security especially.
I think the success of the 12-factor app is vindicated in the fact that people just work this way by default now. You see cloud services designed in this way, platform as a service, designed in this way. Engineers tend to just generally think in this way. At least this has been my experience. Encountering something that was not really in accordance with these practices would surprise me. And I think that would surprise many of the people I've worked with also. So my question to you is, how do you think the changes or the adoption of technologies like Docker and a container orchestration have changed the way that the 12-factor app is applied?
They've changed it, but in some sense, they've drawn from it too, right? So I think that's important to think about as well. Many of the Docker commands look like Heroku commands, Docker run, Heroku run, that kind of thing, right? And that's because they were drawing from those same principles. They really got us thinking about taking things to the next level, because you can't run your own Heroku locally, but Docker it's Docker on your local machine, it's Docker in the cloud, it's whatever, wherever you're running it. That changed the way we think about things like dev prod parity. And in some ways, maybe we started going too far with that. You and I have talked about crazy Docker Compose YAMLs that try to mimic an entire complex infrastructure, many different microservices and databases all working together locally. And at times, trying to sustain that kind of dev prod parity at that extreme ends up being detrimental to your developer productivity. You spend more time keeping that in sync with the production environment than actually just writing code that solves the problem your business needs to solve.
Yeah, that was probably one of my biggest contention points I had after working with the 12-factor app for a while. The inflection point for me was when moved away from working on, say, monolithic applications where there's largely one app, like one code base is just one of everything. It gets deployed and that's it. Nobody has to think about anything else. But as systems become more complicated, there becomes more code bases, like interdependencies between services become really important. The way that environments are constructed become really important. Rules of engagement between services are really important when it comes to, say, can things be deployed in any order, or do they have to be deployed in a certain order because there's dependencies and like what things expect. I think it's important for us to also consider the context for these things. Is something we talked a little bit about pre-show, which was when the guidelines were started, the landscape was different, right? So if we consider what dev prod parity meant, say 8 years ago, it could be something as simple as using the same version of Java on your machine that you would use in production, because things were deployed in a much simpler infrastructure. You'd have, say, a bare metal server, maybe you have a VM, just simpler things. But now, it's more common to have some kind of container orchestration, Kubernetes or whatever. And then if you take it sort of the other end and think, well, if I'm deploying to some sort of function as a service like Lambda or something like that, what does dev prod parity mean for that? Because you can't really have, say, a local dev environment when you're completely dependent on this cloud service. So there's definitely some tension between trying to achieve dev prod parity for the sake of achieving dev prod parity versus focusing on the developer productivity, which is something that you mentioned in the pre-show. If you just read the guidelines today, it doesn't really seem like, it doesn't come to me. What do you think?
Yeah, I think it's definitely a subtext, right? I think the spirit of dev prod parity is, well, there's really two things. One is developer productivity in the sense that if we rewind 10 years ago or whatever, people are writing Java code and they're deploying it into these large on-premise servers that are running proprietary web servers that you can't even run on your developer machine. So you're doing all these crazy things to try and actually get your app running locally. And then you find that everything works locally, you deploy it to prod, nothing works, right? And that was a drain on developer productivity. So what dev prod parity gave us early on as we were moving away from that model was, oh, hey, yeah, like it's really easy to reproduce that bug. It's really easy to make changes, be confident in them, set up my CI/CD pipeline, whatever it is, and get them into prod and be confident that everything's going to work. So when we're thinking about today and more modern architectures, which, by the way, the problem that prevents us from having true dev prod parity, that's because we've moved to the cloud, right? Like now that all these resources are disposable, it's like, oh yeah, let's have these microservices because we can. So this journey brought us full circle or something. It's important to keep in mind that like at the point that dev prod parity is not increasing your developer productivity, then there's something wrong. If you need to use a tool like whether it's Rails or Spring Boot or Node.js where it's hot loading your code and you can just make changes, see it appear in the browser or whatever, that's going to improve your development cycle. The other thing is about disposability. So what you gain from having dev prod parity is a reproducible environment. If you're really sticking to dev prod parity, it means it's easy to stand up a new production environment or a new test environment because it's the same thing everywhere and you've followed these principles and you can do that. It's easy to set up a new developer machine and someone who's just joined your company can commit and ship something to prod on the first day or whatever. So again, if the way you've set up your workflow, your inner loop, your CI/CD, if that allows you to have excellent developer productivity and that disposability, that's what's important. Keep those things in mind as you're finding that happy spot when it comes to dev prod parity.
Yeah. So the way that I kind of find whatever that happy point is start by doing whatever is the least effort required to get something that approximates the target environment. So for example, if say I am building something that's shipped as a Docker image and it's running somewhere, then at a minimum, you'll have some version of whatever your runtime is in the Docker image. If you don't want to develop in a container, no big deal in my mind. Just use the same version of whatever that runtime is on your local machine until you find some regression somewhere in this process. Then if you can prove that, okay, there was an issue somehow related to the runtime or like the setup inside the container image, whatever, then maybe you move some of your development or some part of your overall pipeline to then check that bit and then continually expand out as necessary as you find regressions. Whereas the extreme end of this, you have front-end developers who are running their web application inside a container, inside Kubernetes to just look at CSS in their browser because that's how it executes in production. But speaking to your point about developer productivity, then this is the kind of thing that goes out the window, but they feel like they should stick to this parity thing because supposedly that's a good thing. But no, maybe they never questioned the aspect of the parity is only important if it's helping you with the productivity.
Yeah, I like to say that everything in software is about layers. And I think it's one of those things where you have to cut it off at some layer. So if you are a front-end developer working on some CSS thing, the layer you probably need to cut it off at is above the Kubernetes stack somewhere. I think it's tricky to find that a lot of times, especially when you think about full stack developers where you really are, sometimes need to work through the entire stack of layers. And like very often, I think that's to reproduce a really tricky bug or something like that. So having that ability to reproduce the environment is what's important, not necessarily using it continuously as part of your development workflow.
Yeah, see, and that's one of the other things that I think it kind of leaves the practices open to interpretation, in my opinion. Like you said, you may not want to be doing this continually, but for people who they read the text and think like, okay, I'll just follow that because that's what it says, they don't start to question why they shouldn't do it in certain cases. We talked a little bit about working in a product that's composed of multiple services. Then if you're going to run one, naturally it probably has dependence, like it's dependent on other services that might be maintained by the same team or other engineers in the company, whatever. And then, okay, because in a production environment, all these services are running. Then to start a development environment for one, you need to run all of its dependencies and then all of its dependencies and so on and so forth. And then you get into this tangled mess where if you're not even familiar with any of these other services, but your application expects these to be available, then what do you do? I think if people blindly focus on the goal of achieving dev prod parity, then they're led down this path of definitely pitfalls. And definitely it's something that's unsustainable. It's an unsustainable approach in my mind. And have you encountered anything like that in your experience?
Oh yeah, totally. And even if it is possible, like if you think about an organization that has 100 or more services that are all working together, If a single developer needs to be able to own, operate, and understand all of those services, you do not have a scalable organization. So at a minimum, it's a people problem, but sometimes it's just a technology problem. I always like to ask people, especially that are using Lambda or other function as a service platforms, how are you running locally? The most common answer I get is that I'm not. I'm always very curious to hear what people's development strategy is for those kinds of platforms, because it seems to be like unit test and ship to prod or something. So, but that's a technology constraint, right? Like you can't run AWS locally or whatever the platform you're running on. There's constraints.
Well, unless you get into sufficiently advanced fakes, right? Like local, what is it called? Local cloud, or these versions that exist purely for these purposes. But I wouldn't want to make myself entirely dependent on that level of fakery. But I think that fakes and like mock versions of these services in the development environment are really important. Say, especially if you're developing a single page application and you're just building the front end, you call out to some other APIs, right? Like you don't care. Because part of the other problem too is that, say, not everything has test or development versions of the services that you connect to. Say Stripe, for example, they have their test mode or development mode that you can use. But if you're integrating with some other provider, you don't have that option. Then you have different accounts maybe, and everybody has different accounts. It just doesn't make sense,
Yeah, it's like, here's your one metric service instance. You don't get to stand up a new one every time you want to spin up a new developer machine or something.
Yeah. So the other aspect of this I'd like to get your view on is, if you consider the practices now, like what the technology landscape is and what expectations are on the modern software developer at this point, what, if anything, would you add to these practices?
Number one is security. It's so complicated now. When I think about the apps I was building 10 years ago, 15 years ago, boy, security was an afterthought. HTTPS was not even a thing, or at least sort of an advanced thing. But today, that's got to be done upfront. When you are building out your models, you need to think about what type of events I need to be logging such that I can trace back and see if there was suspicious activity. I need to have all those proper security mechanisms upfront. They need to be a part of that initial design process. So that's definitely the number one thing that I would add.
What would that look like in practice? I'm guessing this would be something like the 12-factor app does image scanning or some sort of automated way to ensure that the application is free of known security vulnerabilities or meets some level of compliance via automated testing as opposed to manual inspection.
Yeah, that sounds about right. If I was going to write it up today, I would take a good look at frameworks like Rails and Spring Boot I've mentioned again. These web frameworks do a really good job of taking care of a lot of those things for you in a way that they didn't even just a few years ago.
Yeah.
In some sense, it's about using those tools properly, not circumventing them. One of the most common things that I see, and you can see this on Stack Overflow, where people actually recommend this, where it's like disabling certificate checking because you're trying to connect to a service and it's like, it doesn't work on my local machine. So here's the code snippet to just disable.
Yeah, who needs certs, right?
Right. Well, but it's hard, right? People, especially more junior developers who don't understand how this whole negotiation and verification process works, that's really confusing. So I think it's about making the right decisions up front, especially for people who do understand those things. You're setting up a development environment and a production environment where you don't have to take a step like disabling security or disabling certificates or whatever it is. Okay,
so that's security. Anything else?
Yeah, the other one is telemetry. And I think more broadly, like observability. We need to think about our applications as spacecraft. And when we deploy these things into the cloud, they're not coming back. So whatever we have sent them with, the instrumentation that we have sent them with, that's all we've got. That's the only way we're going to know caused that weird bug, or God forbid that they're compromised, there's a security problem. That's the only way we're going to get records of what happened. So that kind of instrumentation that allows you to gain insight into how your applications are performing, it needs to be just as essential as many of the other factors like dependencies and config.
Yeah, that was one of the things that I also flagged in the 12.1 factor app, which was these applications have to have telemetry, especially if the pitch is these practices enable continuous deployment, thus they predicate on continuous delivery. Then by design, you need telemetry. You need telemetry to understand if the application is functioning correctly. You need telemetry to verify that whatever change that you've released is in fact doing whatever it's supposed to do. All of these sort of higher level engineering outcomes like continuous delivery are predicated on telemetry. This sort of leads me into the next question regarding security aspect of this is if we consider the idea of sort of the overall CI/CD pipeline as a factor of the application. Like when you design your application, you have to design it in such a way that area X can be exercised by some automated test pipeline, area B, so on. One of these areas is compliance checking. If you don't think about that from the beginning and bake that into sort of the automated pipelines that ship your application, then it's going to be more difficult than if you didn't, especially at the beginning. And this speaks to some of the other things like testing, for example. Like it's all assumed, right, that we'll have automated testing. But what kinds of things should be covered by the test suite? One of the things that I call out in the additions to the config factor is the idea of having some kind of dry run mode for the application. I don't know if you have worked with Ruby or like dynamic languages, for example, but I would be hit by problems where I had some error in the, say, production.rb file, but that file was only evaluated until I went to prod. So it actually was on Heroku. I would push to Heroku and then the app would blow up in production because of this error. And that was the first time the code ever been executed. So after hitting these kind of stumbling block more and more times, like, okay, no, there's a better way to do this. And I came to the conclusion that having this dry run mode was a fantastic way to smoke test that there's like free of these kind of regressions. If you bake that into the application, then you can bake that into the delivery pipeline. And you can assert that the application is free of these type of regressions.
Yeah, I think that aligns pretty well with what we were talking about with regard to dev prod parity too. When we were talking about it, the way I actually think about it is like modes, right? I have this development mode where it's maybe a little bit like prod, but I still get the hot loading of code and things like that. And I can adjust that until I have either a production mode or, as you said, a dry run mode. Mm-hmm. And I think in the same sense, as we were saying with the dev prod parity factor, I think it really comes down to disposability, but really the characteristic is about reproducibility and being able to have those different environments and to do those things easily.
I think the more that we talk about the dev prod parity factor, the more that I think it's more open to interpretation than I originally thought. Like it's one of these bigger things that you can, like in some way, it can come under that umbrella. So when I talk about the dev prod parity, I try to be as explicit as possible in that, say, if your application connects to a database, then you should use the same version of that database locally. Now, this is trivial. It's like trivial easy compared to how it used to be because you can use a Docker image to run any version of anything at any point in time, and you can have all these versions running at the same time too. So you can even cross version test. That is the basic level, and what you mentioned earlier of, say, runtime parity and dependency parity of system packages, application packages, all these kind of things. That's where my mind goes in terms of dev prod parity. But it seems like you have a broader vision for what's part of this whole thing,
Yeah, I often call dev prod parity the gateway factor because you work towards that. And again, I totally agree with you on how it can be up to interpretation. But as you work towards that, you're doing all these other things, right? Mm-hmm. Like separating your configuration from your code so that you're not connecting to your production database by accident from your local workstation. Your build, release, run process, which is part of your CI/CD and lends to your development environment. The way you bind to ports rather than port binding is actually a really good example because that's another one where a lot of people read that and they're like, what the heck is this about? I don't understand. But you have to go back 15 years ago when people were deploying, well, some people still do this, but WAR files running server, right? Mm-hmm. Like their application had no concept of handling HTTP requests. It was just this app with handlers that was dropped into a running web server that did all the HTTP stuff. And the port binding factor was really about inverting that model so that your web server became a dependency of your application. And this is all very natural to Ruby developers for the most part. But in other language ecosystems, it's not.
Yeah, that's the funny part. Like how much of these interpretation of these practices is influenced by maybe the language you grew up in or the ecosystem that you got most of your experience in. As you say, working with Ruby is far different than what it was working with Java, especially 10 years ago.
Yeah. When the 12-factor app was written, Ruby was the vanguard, and the majority of the industry was doing PHP and Java. Actually, I take it back. I think the majority of the industry is still doing PHP and Java, but That doesn't change the fact that the state of the universe is very different.
So as a little quick reality check there on that one. So speaking of PHP, is interpreted in the context of something else, right? So to use the analogy of Java and WAR files, you have your PHP code, but then your application server is something like Nginx or Apache. So in this case, does PHP violate the 12-factor app in the strict definition unless you were somehow going to bundle your quote app as the combination of, say, like Nginx/Apache and PHP code?
I think it depends how you're using PHP. I think PHP, like Java, has this long history and a lot of different ways to do the same thing, right? But there are definitely advances in that ecosystem. I'm a little bit out of my wheelhouse here, but I think it's Composer that has changed how dependencies are managed in PHP. There are definitely parts of that ecosystem that have come forward. And I have friends that are PHP developers and swear by some of the best practices. I think any tool that continues to be used in production, there are reasons for it. And some people get a lot of value out of it.
Oh, yeah. One thing that's been really helpful for me as just somebody who has moved across a lot of different languages, a lot of different stacks, is using the 12-factor app guidelines just as a yardstick to assess how different technologies mesh with this way of working. And one of the pain points is when you deal with the runtime, say like PHP, where you have like application level configuration, like whatever PHP code you have, but then you have the INI files that you have to also configure to set stuff like thread pull limits and blah, blah, blah. It's totally separate. And of course, those likely don't support some level of environment level configuration. Then you end up in some shim type solution, which will read the environment variables and modify the files before starting the thing. And you get into this shim layer. Then you go to other technologies where like, oh, they just work that way. You don't have to think about any of this kind of stuff. And to me, this is a virtuous feedback loop between the 12-factor app principles and software design. And I'm curious, I want to get your view on this and I'll let you go, which is one thing I proposed in the 12.1 factor app is the adoption of hexagonal architecture. And this speaks to your point about disposability. The reason why I suggest hexagonal architecture is because it enforces the creation of the boundaries between the service, the code that we're writing, and I think as it's called in 12-factor language, like backing services. Such that if you have this boundary in place and you have the configuration, like separate configuration with environment variables, then in theory, you should be able to say, just change the environment variable, then use a different version of this. Like you could use a fake in development. You could use this version in staging or this version in prod or whatever. But that requires you actually adopt a certain way of architecting your code as an application developer. So how have you experienced that kind of feedback loop and how have you seen that play out in your experience?
Yeah, I think the backing services has this intention to it, which is really about decoupling. And very similar to the way we think about a microservice architecture and what we were saying with if you're in an organization with 100 services, you shouldn't be responsible for all of them. That's very often the way you should treat your database or a third-party service. And that decoupling of the application from whether it's a database or another microservice or a third-party metric service or whatever it is, that's the spirit of that factor. The use of environment variables to do that, I think, is a good recommendation. But even on Heroku, we're finding that doesn't get us where we need to go sometimes. That can at times make it difficult to manage secrets among your team, where it's you don't want everybody to have access to the same things. It can also make it difficult to like role credentials and things like that. So there are other models. You can write these things to disk and have them read from disk, but those are in some sense implementation details. Right. The important part is that decoupling.
Exactly. Once you have it decoupled, you don't care where the configuration comes from in a sense, right? Like if it's this shim thing that I mentioned that's doing this or some config map or secret mounted as a volume inside your Kubernetes pod, like it's all fine. It doesn't really make a difference because the focus on separation of concerns. If you take that factor up the levels of abstraction, I think that's where you get the most benefit from that because of the positive effects it has on your application architecture. Well, Joe, thank you so much for taking the time to come on the show and talk to us about the 12-factor app and have a little back and forth about the 12.1 factor app. Seems that we are overall aligned in how we think about some of the stuff, but it's always great to hear somebody else's perspective on this. So is there anything you'd like to leave the audience with before we go?
Yeah, something I've been spending a lot of my time on lately is the Cloud Native Build Packs project. which is very much related to the 12-factor app. Build packs are the mechanism that we use on Heroku to make the platform application aware. So when you send your source code to Heroku, we detect what kind of app it is. We prepare it for production. That's what allows you to just have source code that you work on locally, send it up to the server, and poof, it's running. It's also what allows you to focus on processes in your application rather than servers and infrastructure and things like that. So the Cloud Native Build Packs project is an effort to both modernize the build pack concept and bring it into the Docker and container ecosystem, but also democratize it. Because today, build packs run on Heroku and that's it. Well, there's some other platforms like Cloud Foundry and Deis and things like that. But Cloud Native Build Packs is by design its own standalone project. And it's something that you can adopt without using Heroku. It's something that you can run locally. You can build it into your own CI/CD process and bring your applications into the container ecosystem without breaking the fourth wall, right, which I use as a euphemism for writing a Docker file and keep moving down the stack and taking on all these concerns. Build packs offer a better abstraction, but still play well with the container ecosystem. I encourage you to give it a try, buildpacks.io. We have a CLI that runs on Linux, Windows, and Mac, and you can run Heroku build packs on your local workstation.
Great. We'll have to give it a try. We may do an episode on that one in the future. Well, Joe, thank you so much for talking and hope to talk to you again.
Yeah, it's great to be here. Thanks.
That wraps up this batch. Visit smallbatches.fm for the show notes. Also find Small Batches FM on Twitter and leave your comments in the thread for this episode. More importantly, subscribe to this podcast for more episodes just like this one. If you enjoyed this episode, then tweet it or post it to your team's Slack or rate this show on iTunes. It all supports the show and helps me produce more Small Batches. Well, I hope to have you back again for the next episode. So until then, happy shipping. Want to learn more about DevOps without wasting your time? Then sign up for my free email course at freedevopscourse.com. My course combines the best from the DevOps Handbook, Accelerate, and years of software delivery experience. You'll learn the 3 ways of DevOps and the 4 KPIs of software delivery performance. More importantly, I'll show you how to put that theory into practice. That means shipping better software faster. Sign up today at freedevopscourse.com. Like the sound of small batches? This episode was produced by Podsworth Media. That's podsworth.com.